Hello guys, welcome to our class. Today we are going to be looking at equilibrium of forces. We are going to be looking at equilibrium of forces. So please, if you have not subscribed to our channel, please subscribe to this channel and click on the notification bell. This is Normal Science Tutors Online, and we are bringing physics class direct to your doorstep. That's okay. So we'll be working on this channel and we have covered a lot of topics, so you can go to YouTube, check all the topics that we have treated, and now we are going to treat equilibrium of forces. So please invite your friends so that they can come and enjoy what you are enjoying. Get your writing materials ready. You can reach us via the WhatsApp number that is showing on your screen, and I remain Otobo Michael. So welcome to this class, and once you are ready, so let's go straight to our class. As I said, we are going to be treating equilibrium of forces. Equilibrium of forces. Okay, so when a body is in equilibrium, it is said to be in a state of the body is said to be not accelerated. That is the body is like in a state of rest. Okay, the body is in a state of rest, so nothing is disturbing the body. There are no external forces acting on the body, and the body is stable at rest. So we can say that that body is in equilibrium. Is that okay? So there is no net force acting on the body in any direction. So when the body is at rest, the body is said to possess static equilibrium. Static equilibrium. Static is in one position. But when the body is in a state of constant motion with constant velocity in a straight line, or when it is rotating with constant angular velocity about a fixed axis through its center of mass, the body is said to be in a state of dynamic equilibrium. Dynamic is motion, right? So the body is said to be in a state of dynamic or kinetic equilibrium. Okay, so when we're talking about equilibrium of forces, we're also talking about balancing of forces. So we'll look at the resultant of forces. Resultant of forces. So what is the resultant of a force? That resultant is a singular force which, acting alone, we have the same effect in magnitude and direction as two or more forces acting together. Okay, so what that simply means is that, like in this direction, in this particular diagram, you have two forces P and Q acting at a point. Okay, so you have P and Q acting at a point, and then there is this balancing force, equilibrium force. So the resultant is that singular force, which, acting alone, we have the same effect as two or more forces acting together. So this arrow here is the resultant, right? This arrow is the resultant. So from the above diagram, the resultant of the two forces P and Q is a singular force arrow, which is equal in magnitude but acting opposite in direction to the third force, this third force, which is the equilibrant. So this force that is acting opposite to the resultant force is called the equilibrant. It's called the equilibrant. The equilibrant of two forces is that singular force which balances all the forces taken together. It is normally equal in magnitude and direction to the, it is equal in magnitude but opposing the direction to the resultant force. Okay, so what is here is just what I've stated. This is the equilibrium force, and then this is the resultant force. The equilibrium force is acting opposite in direction to the resultant force, but it is equal in magnitude to the resultant force. So this resultant force is a singular force that replaces these two forces acting together at that particular point. So these are basic definitions that we need to take note of. Okay, so we'll move on to triangle of forces. Okay, determination of resultant and equilibrant of forces. Okay, so if you have that pictorial representation I just discussed before, that can be represented on this diagram. Okay, so this is F1 and this is F2. They are acting at this point. So this is the equilibrant and then this is the resultant. So the result of the force can be determined by the parallelogram method. And the parallelogram method states that if two forces acting at a point are represented in magnitude and direction by the size of the parallelogram, the diagram drawn from the points of intersection of the two forces represent the resultant. So the diagonal drawn for the point of intersection represents the resultant, and the force that is acting opposite direction but with the same magnitude to the resultant is the equilibrant. So mathematically, the resultant can actually be calculated using the cosine rule. So please, you need to review your cosine rule in mathematics. Okay, but this is what that is what I've stated here. You know, the cosine rule is applied when you have a triangle with two sides and an included angle. You can use the cosine rule to actually find the unknown side, which is the top side, or the unknown angle, or the included angle if you have all the three sides given to you. So like this now, you can actually extract this triangle from this, and then you have something that looks like this. Sorry, my diagram might not be too perfect, but you will manage it with me, right? You manage it. So this can be your B OC. So if you follow this drawing, you see that this side is equals to F1 and this side is equals to F2. Then this is the included angle and then this is the resultant. So you have here, this is F1, F2, and then you have this included angle, and then you now have your resultant. So if you review your cosine rule, you find that for you to find this side, it will be r squared is equal to the sum of the squares of the other two sides that are given to you minus f2 f1 two times then cosine of the angle that is opposite to r, which is cos theta. All right, so this is the cosine rule, and I'll actually want you to review it because you will need it to solve problems on this determination of resultant of forces or of equilibrant. Okay, so you need it to solve some problems on this. Okay, so this is a question I will need to solve. Two forces 10 Newton each are inclined at 220 degrees to each other. Find the singular force that will replace the two forces. Balance the given force system. Okay, so this is a drawing, and then this is a drawing, and then we can just have the triangle look like this, so that we can have the triangle look like this, and then we have our 10 Newton here. This is also 10 Newton. Then this is your arrow. Okay, so have a force system like this. Okay, so this is the angle. You don't know this angle yet. Okay, so then this is the alpha. So basically we brought this BCO there. So this is BC is BCO triangle that we brought here. Okay, so in this triangle we have two sides, then we will look for this angle first before we can apply the cosine rule to solve for r. Now for us to get this angle, we know that the total sum of angles in a parallelogram is equals to the total sum of angle in this parallelogram is equals to 360 degrees. Now opposite angle AOB AOC and ABC, they are equal. So this is 120 and this is 120. Now for you to find angle E and C, first of all find the sum of these two angles AOB and AOC. So the sum of the two angles is equals to AOB plus ABC is equals to 120 plus 120. So that gives us 240, right? Okay, so for us to find angle A and C, we know that angle A and C are also equal. So first of all, we'll subtract this from 360. So that will give us 360 minus 240. That gives us 120 degrees. Now, since OAB is equals to OCB, so you say since OAB is equals to OCB, OAB is equals to OCB, so we have that angle OCB will be equals to so we have that 2 OCB is equals to 120 since the two angles are equal. So angle OCB will be half of it, right? So that will be 120 over 2, and that will give you 60 degrees. So that angle here is equals to 60 degrees. Theta is equals to 60 degrees. So once you have gotten that, it becomes easy for you to apply the cosine rule. So according to the cosine rule, say that r squared, because the cosine rule, as I said, is applied to a triangle where you have two sides and an included angle. So in this case, we have these two sides and this included angle, right? We have these two sides and then this included angle to find this side. So for us to find this side, the resultant, we have r squared is equals to 10 plus 10 minus 2 times 10 times 10 times cos 60 degrees. Remember the formula that we just quoted before, right? So when you remember the formula, this is exactly the formula we quoted before: f1 plus f2 minus 2 times f1 times f2 times cos theta. Okay, so this will now give us this is 10 squared. Okay, so this will now give us 100 plus 100 minus 2 times 100, that is 200 times cos 60. Now cos 60 is equals to 0.5. Cos 60 is equals to 0.5. Okay, so this will be 200 minus 200 times 0.5. So this will be equals to 200 minus 100. That gives us 100. So r square is equals to 100. Now find r by squaring this other side. So square root of 100 is equals to 10. So resultant force is equals to 10 Newton. Okay, so this how to apply this cosine rule. Then we said that the force that will balance this force system is the force that is equal in magnitude to the resultant force but opposing the direction to it. The force that will balance is force that is equal to the magnitude but opposite to it. So which means that the equilibrant is also equals to 1080. So the force that will balance this one is also equals to 1080. Okay, so this is it. All right, is this so? With this one now, you have been able to get the resultant, and then you have also been able to get the equilibrant. Now you can find the angle of action of the resultant using that by looking for this angle alpha. The angle of the resultant to the 10 Newton force, you can find it by using this alpha, by using this, and that will involve you using the sine rule. But yes, so that will involve you using the sine rule. So that's okay. So you can check your I want you to go to your start to go and review your cosine rule and your sine rule, because you will need them if you want to solve any problem on this. You know that the sine rule says that assuming you are considering this particular triangle BOC, if you are considering this triangle BOC, the sine rule states that sine, that is the side that supposedly that is like the sine rule. Okay, I have to relabel this triangle so that it will be easy for you to understand a little. So the sine rule, if I label it according to the figures or the alphabet O, and this is B, and maybe this is C, it stays as C. Okay, this one stays as C. The C is equals to R now, C over sine C is equals to B over sine B is equals to O over sine O. So as the case may be. So depending on the type of triangle that you are given, you can actually use this one to find. If you have two angles on one side, you can use the sine rule to find the other side. Okay, so this is the statement of the sine rule. I'll actually like you to review it so that you can use it to solve some problems. Okay, so let's go further. This is the principle of triangles, just like the principle of parallelogram that we just stated. So this principle states that if three forces are in equilibrium, just like it's in this picture, they can be represented in both magnitude and direction by the sides of a triangle taken in order. So if you have two forces P and Q, if they are in equilibrium, then the side of the triangle can actually be used to represent them. That's okay. Then the resultant of these two forces is the force is the singular force that can replace them, and it is counterbalanced by this E. Now this triangle, we can actually bring out this part of the triangle. You have COA. I know I've discussed this particular stuff before. Then you can represent this triangle in this format, and then using the sine rule. This is now the sine rule. This is the sine rule that I mentioned before. See, so you state the sine rule according to the labeling of the triangle. So this is P sine C, Q sine O, and E sine E. Right? So this is the statement of the sine rule. As I said before, please review this sine rule so that you know how to apply it to problems on triangles. So you can go to your simple geometry and then know how to use the sine rule to solve some problems on a triangle. Okay, all right, so let's see some other problems again, and then okay, so let's see some problems on this principle of triangle of forces, because I believe that the more problems you solve, the more better acquainted you will be with any topic that is treated. Okay, so let's look at this particular problem. Say a body P, as shown in the diagram above, is in equilibrium. If the mass of the body is 10 kg, calculate the tension on this string. Now know that the mass of the body is acting downward, and they said it is 10 kg. Okay, so this particular one, you can actually represent it in a diagram. This force is what is acting, this force, the mass is actually acting downward vertically. Okay, so this one is acting downward vertically while this is acting horizontally. So you can actually draw a triangle to represent these forces. So if you draw the triangle, your triangle will look like this. Please, even if my lines are not straight, know that what I'm trying to draw is a straight line. Please, what I'm trying to draw is a straight line. Okay, so I want you to pardon me and accept this as much as I can. Okay, so please accept it. Try and draw your own and make it to be straight. So this is the width of the body. This represents the weight of the body, which is 10 kg or 100 newton. Multiply that by that, acting vertically downward. Okay, then this is the string, a tension T, that makes this angle with the vertical. Then this is the force that is pulling this horizontally. So simply put, we have been able to draw this triangle of these forces. So once you are able to draw this triangle of forces, it becomes easy for you to find the tension. Okay, so if you look at this from your trigonometry, this is adjacent and this is the hypotenuse. So we say that cosine theta is equals to adjacent over hypotenuse. Okay, so your adjacent is 100 Newton, and then your hypotenuse is what you are looking for. So you can see, so you write this as cos 60 degrees is equals to adjacent 100 all over t. So cos 60 is 0.5 is equals to 100 over t. So t is equals to 100 over 0.5. So by the time you divide that out, you're going to have 200 Newton as your tension in the string. So guys, basically what you need to do or try to understand is how to draw this triangle of forces out. Now look at it. This is the vertical and this is the tension. So the tension is making an angle with the vertical. So, and that is exactly what I drew here. This is the weight that's acting vertically downward. Then this is the tension, and then this is the force that is pulling it horizontally. Okay, this is the force that is pulling it horizontally. So please, I hope you understand this. So let's take another question too. We need to solve another problem. Okay, so this is another scenario. Now, this one says that a body of mass 0.5 kg is suspended by a string and pulled by a resultant force of 12 Newton as shown in the diagram above. Calculate the tension T in the string if the body is in equilibrium. So if the body is in equilibrium, it means that the body is balanced. So now we need to represent all this in a diagram. First, we know that the weight of the body is given to us to be 0.5. So this is the weight of the body that is acting vertically downwards. Okay, this is the weight of the body that's acting vertically downwards. So if you multiply that by 10, it will give you 5 Newton. Okay, so having said that, we need to draw this diagram just as we did before. This is acting downward, and this is making an angle with this vertical, and this is pulling it horizontally. So which means you are going to have a triangle of force that look like the one we did before. Okay, so you are going to have something that looks like this. Wow, so this time I think I tried to draw this one better a little. Okay, so here this is the force that is pulling vertically, and this is 12 Newton according to the diagram. Then this is the force that is pulling downward, and this is the weight, and this is 5 Newton. And then now you are asked to find a T. You are asked to find T. Okay, so if you look at this, this is a right angle triangle, and from your trigonometry and from Pythagoras theorem, you say that T squared is equals to 12 squared plus 5 squared. So you can see that once you can draw the triangle out, to solve the problems on this, they are not really hard. So 144 over 25 plus 25. So this gives us a 169. So t squared is equals to 169. Then t is equals to the square root of 169, and that gives us 13 Newton. Okay, so this is 13 Newton. So guys, if you actually take your time, you find out that these questions, they are not really too hard to solve. Sometimes the diagram can just overwhelm me, but if you take your time to break down the problem very well, it becomes easy. If you can draw this triangle, then your problem is half solved. That's okay. So that is it. So this is also another question, still on this triangle of forces. This is another question. Question says, a picture of with 4 Newton supported by a string on a nail as shown above. So this is a picture, So find the tension of the strings at A and B. If the strings are each inclined at 70 degrees to the vertical. Okay, so this is your diagram. This is your diagram. Okay, so if you follow the principle of moments, the principle of moments says that upward force is equals to downward force. That is a statement of the principle of moments. Is that okay? So for this particular setup, we can also draw the triangle of forces. Okay, so the 4 Newton, which is the weight, is actually acting downward. It's acting downwards. So we can take that first. Take that first. So this is acting downwards. Sorry for my drawing, please. It's acting downward, which is the weight that's acting downwards. So these other two forces are making an angle of 70 degrees with the vertical. Okay, so you have the vertical force, vertical angle. So this is 70 degrees, and this is also 70 degrees. So you can now have a triangle that looks like this. Okay, so if this is 70 and 70, we know that the total angle in the triangle is 180 degrees. Okay, so which means the angle B will be equals to 40 degrees. That is 180 minus 140. I hope that one is clear now. Simple mathematics. Huh? So this is 40 degrees, and that is this angle B here. Okay, so from this now, we have completed this triangle. Now we are asked to find the tension we have to find the tension on the string. Okay, so here the formula that we can use is the sine rule. So from the sine rule we have that T all over sine 70 is equals to 4 all over sine 40. Okay, so if we have this, we can actually make T as subject of formula, so that we'll have that T by cross multiplying, and that T is equals to 4 times sine 70 all over sine 40. So if you find the sine of these angles, you have 4 times 0.9397 all over sine 40, which is 0.6428. Okay, so when you work all this out, you will have that T is equals to 5.85 Newton. So remember that the T, they are equal. So this is the value of the tension on the string. Okay, this is the value of the tension on the string. So this is how to go about this problem. But if you don't want to go through this route, then you can also say that from the principle of moment, the upward force is equals to the downward force. The upward force is equal to the downward force. Now, if we take this as F1 and this is F2, so we can say that F1, the sum of the upward force plus F2 is equals to 4 Newton. Okay, so if this is F1 and this is F2, then we can actually find from your trigonometry, if you consider this triangle, say assuming this triangle A O B, okay, there's B there already, so we can say OAC for this triangle, and don't forget this is a right angle, so we can actually find this to be cos theta or cos 70 is equals to cos 70 is equals to adjacent over hypotenuse, that is F1 over T, so that your F1 is equals to T cos 70 degrees. Is that okay? So similarly too, for this triangle BOD, if I say D here, similarly to F2 will be equals to T cos 70. So if we equate that, if you put this into this equation, we'll have that T cos 70 plus T cos 70 is equals to 4 Newton. So we can work this out, right? We can actually work this out. If we work this out, then because this will now give us 2t already we have, okay, so this will give us 2t is 2t cos 70 is equals to 4 Newton. Alright, so we can work this out. So we can actually work this out. Sorry, I think I can clean this. We have used this part already to solve our problem. I'm sorry, but I think I just need to explain this other procedure too, so that in case you are in examination hall and you need to use any of this formula to solve. So this you can write, okay. So you have t 2 t cos 70 is equals to 4 Newton. Okay, so t will be equals to your t will be equals to 4 all over 2 times cos 70. So you can just point that out. You have 4 all over 2 times cos 70 is 0.342, and if you work this out, you have your t will be equals to 5.85 Newton. Okay, so whatever method you feel like using, you can either draw the triangle and use it this way, or you can follow through this method that from the principle of moment, the downward force equals to the upward forces. It's equals to the sum of the upward forces. So these are the upward forces, and this is the downward force, the weight of the picture, and then you can relate it and then solve. Very easy. So in the two cases, you have the same answer. Okay, so that is what we have. Okay, so thanks. This is your test your understanding page. These are simple questions from JAM. So try to solve them and then get your answers readily. Okay, so we'll solve all these problems first. So I don't think this is exactly like the one I did now. It's exactly like what I did now. So you can just solve that one, and then this one too. Very simple. Right, so thank you guys. I think that's where we're going to stop this class for today. But before I leave, please, if you have not subscribed to our channel, what are you waiting for? Right, so please subscribe to our channel, click on the notification bell, give us a like and give us a thumbs up, so that when we upload a new video, YouTube will notify you. This is Normal Science Tutors Online. We thank you so much for your time, and you can reach us via the WhatsApp number that is showing right on your screen. Okay, so thank you, and please continue to be a diligent student, apply the principles, and you'll find out that gradually physics will become as simple to you as any other subject. Okay, so what we're doing is we're trying to make sure that we make physics as simple as possible, and that's why we're taking all this time to present this lecture in the simplest manner that we think we can do it. So thank you so much. We hope to see you in our next class. Thanks.